So like I've been saying this whole year, the important part or the hardest part of calc is interpreting what they mean. So take a minute and read through number 1 and see which answer choice you think it would be, A, B, C, or D. Okay, if you think A, hold up a number 1. If you think B, hold up a number 2. 3, hold up a number 3. 3, well. C, hold up a number 3. And 4, hold up a number D, or number 4. I have up. A is 1, B is 2, C is 3, and D is 4. So what do you think for number 1? A, B, C, or D? Hold up a finger, please. Okay, so I see a couple 1s, a couple nothings, a couple 4s, a couple 4s, 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 okay? So what's the difference between 1 and 4 then? So A says the average temperature of the water in the tub from 0 to 20 is 16 degrees. The problem with A is that there is no average. So average is out in front with a divisor, where D says from 0 to 20 minutes, the temperature of the water in the tub increases by 16 degrees Fahrenheit. The answer is D. Okay, number 2. As a pot of tea cools, the temperature of the tea is modeled by the differentiable function h, where t is measured in minutes and h is measured in degrees. Which one represents the interpretation of the derivative of h at 3.5? Equaling negative 8/3.
Aaron Plants, please come to the office. Aaron Plants, please come to the office.
Give me a 1, 2, 3, or 4. Okay? Got a 1, 1, 1, 1. Okay. Alright, so correct answer is in fact A. A derivative is a rate. So that really left D and A as potentials because they both had the words change or rate. Couldn't be B or C. There's no averages occurring. Okay, number 3. Same setup, but now we have an integral instead of a derivative, and we have a 1/10 out in front. Remember, h of t is in degrees Celsius. At 0 to 10 and 1/10 would be in minutes. The minute I see a fraction in front of my integral, what should I be thinking? What word? You see a fraction in front of the integral, you're thinking one word. There's only one of these answer choices that has that word in it. Average. Therefore, the correct answer is D. Good. That 1/10 means you're finding the average. You're going the beginning to the end and dividing it out. Okay, number 4. Time is minutes. Velocity is meters per minute. Explain the meaning. Okay, the minute you see an absolute value. What does an absolute value of velocity tell you? I think someone said it. What's an absolute value tell you? Not C. Oh, speed. I was like, it's not C. Yeah, so absolute value of velocity is speed, meaning everything becomes positive. If everything becomes positive, what does that do to your answer? The absolute value of velocity in terms of its integral now, so if you take the integral of speed, everything's now positive, therefore it's total distance. You're not taking into account any backwards movement. The integral of velocity without absolute value gives you displacement. I'm going over and using these because this was something we goofed up on our mock exam. This was an area we had issues with on our mock exam. And directly leads into where we're going today, which is looking at integration in terms of net change. So today we are looking at integration in terms of net change. We're going to compare distance versus displacement with integration. I'm going to be looking specifically at distance and displacement with integration. So displacement represents change in position. Displacement represents change in position. So if you take 2 steps forward and 1 step back, you're currently going to still be a step backwards. Or sorry, a step forwards because you only ran backwards 1. However, you walked 3 steps. So total movement versus location. Displacement is more like your current position. Integrating velocity gives position. Integrating velocity gives position, which gives the displacement at point B. So we say in order to find your new location that your new position is equal to your initial position plus displacement. So we can rearrange these, and again, the rearrangement of this all goes back to what? Rearranging these terms, finding that net change, all directly goes back and relates to the fundamental theorem of calculus. New position is equal to initial position plus displacement. So writing that out would look like S of B equal to your S of A plus your integral. which again all goes back to FTC. Total distance is a little bit different because total distance is now the absolute value. Total distance is the absolute value of that velocity. Thus, there is no negative direction. So what happens is if you're integrating an absolute value of velocity by hand, we sometimes have to break our curve up into multiple parts. So to find total distance, which we did, if you think back to position velocity acceleration unit, where to find that absolute value of velocity before, you had to find the zeros and take positions and subtract them and sum all of the displacements together, taking into account forward and backwards movement then as well. For those of you in physics, I'm sure that's something you have to do in there as well. Taking into account a bouncing ball and potentially the up and down movements we get broken up as well. Okay? So it says, suppose the velocity of a particle is moving along the x-axis given by the velocity function there. We're looking at the particle from 0 to 2 seconds. We want to take into account when the particle is moving to the right, to the left, and stop. So if we're given velocity now, then we need to find when velocity is 0, so you get 2 times at which the velocity is 0, 1 second and 2 seconds. So to determine if the particle is moving to the right or the left, I need to know if the velocity is positive or negative. So from 0 to 1, you could plug in something like a half. So 6 out in front isn't going to change the sign. A half minus 2 is negative. A half minus 1 is negative. A negative times a negative is a positive. Therefore, in words, the particle is moving to the right from 0 to 1 because v of t is greater than 0 or positive. That is the written justification. This number line means nothing to the AP exam grader. They won't even look at it. It's as if it's as invisible as it is on my screen now. They won't look at it. You have to be able to verbally write down what that number line represents. And then you would say the particle is stopped at t equals 1. Because v of t equals 0. And then you have to find out what's happening from 1 to 2. And that would be like plugging in 1.5. So 1.5 minus 2 is negative. 1.5 minus 1 is positive. Negative times a positive is a negative. So the particle from 1 to 2 is moving to the left because v of t is negative or less than 0. And do not forget your last endpoint. The particle is stopped at t equals 2 because v of t is equal to 0. Because 2 is included in my interval, we need to make sure we list it as being stopped. So keeping all of that in mind, we're going to take into account the next part. So it says find the particle's displacement for the given time interval 0 to 3. So if our time interval is on 0 to 2 seconds, this represents my initial. So remember that we are looking for final, which is initial plus change. So s of 2 is equal to s of 0 plus the integral from 0 to 2 of v of t dt. S of 0 is 3. The antiderivative of velocity would be 2t cubed minus 9t squared plus 12t evaluated from 2 to 0. So it's 3 plus 2 times 8 minus 9 times 4 plus 12 times 2. And then everything at the end would be a 0. So you have 3 plus 16 minus 36 plus 24. Which, sorry, not 24, is 4. And again, we're talking about a particle. We weren't given any initial units, so it would just be 4 units, because we weren't told feet or meters, etc. Part C is the second thought, which is total distance. So again, like I said, total distance comes from taking the absolute value it does not necessarily take into account that initial starting. What it does take into account, though, is where is the object stopped. So where it's stopped and changes direction does matter for distance. So to find the total distance without a calculator, you have to break your integral into parts where it changes position. So we have to look at the integral from 0 to 1. And if it's negative, like it is from 1 to 2, we have to subtract the negative distance away to make it positive. So the area under the curve from 1 to 2 would be negative because it's moving backwards. So if I subtract a negative area, that makes it positive. So this is kind of like S of 1 minus S of 0 minus S of 2 minus a minus or a plus S of 1 again. So we were told S of 0 is equal to 3 in part B, or you could find it by plugging in. We found our position function because we were given the velocity. We could find the antiderivative of velocity. So S of t would have been equal to 2t cubed minus 9t squared plus 12t. And then your initial point was that 3. So you have position. Or you could antiderive in each of these and plug in. So S of 1 becomes 8. S of 0 is 3. We just found, or we can find S of 2. Which is 7. And then S of 1 is 8 again. So 16 minus 10 is 6. Total distance is 6, sorry, not meters. So used to writing M, units. Sometimes it's hard to see that with just looking at an equation. You could actually use your calculator to verify. So if this was a calculator question, then on your calculator you could have done there we go. On your calculator you could do math 9, math 8, math 9, sorry. Hit 8. And then you would do 0 to 2. Go to math, go over to num, hit absolute value. Now type in your equation. And you see that we get 6 once again. If I did that and I removed the absolute values, I wouldn't get the same parts. I would get 4. So we can see here we have 4. Okay. Go back. So let's look at something graphically now without an equation. So again, this goes back to a lot of FTC. Initial is 10. What is the particle's displacement between 0 and C? So here's C at the very end. So displacement is different than total distance. Displacement is a sum of all the parts. So you take a positive 10, a negative 9, and a positive 8. And we get a displacement of 9. So that would represent the integral from 0 to c of, it looks like b of f. Total distance would be the absolute value of that. So now it would be the absolute value, so it would be 10 minus a minus 9, because you'd have to flip AB so that it is above, plus 8. So you add that 9 instead of subtracting it now, thus giving 27 inches. Position, so x of 0 is 10. X of A would be equal to 10 plus 10, because you've moved 10 more units to the right. So it's 20. X of B would be that 20 minus the 9 units going backwards, which is 11. And x of c would be that 11 plus 8 forward, or 19. So again, this 9 inches doesn't represent its location, it represents its displacement. The particle's location at x of c is 19. Because it takes into account the initial plus the displacement. So x of c is initial plus displacement, which is 19. Going back to where we came from, it says, where does the particle achieve its greatest negative acceleration? So a particle is going to achieve its greatest negative acceleration at a point of inflection. It's going to achieve its greatest negative acceleration at a point of inflection, which on this graph would be at A. So the slope of the line is the steepest, and the graph changes concavity. Approximately, where does the particle achieve its greatest positive acceleration? So now this is going to be at point B, because once again, it is changing from concave up to concave down, as well as being extremely steep and positive. The graph of the velocity of a particle moving on the x-axis is given below. The particle starts at x equals 2 when t is equal to 0. So we have totally different movements. You have from 0 to 1, it's at 1. From 1 to 2, it's at -1. From 2 to 3, it's at positive 1, and 3 to 4, it's at negative 1. So forward, backwards, forwards, backwards. So find where the particle is at the end of its trip. That's our displacement. Plus our initial. So its displacement is 2. Because the particle from 0 to 4 went no units. And its initial position was 2. So its displacement was 0. Because it went forward, backwards, equally. So the particle is 2 units away. Now, total distance is a different picture because the total distance takes into account all of those position changes. So every time you go forwards or backwards, it gets added to the sum of the parts. So you have the minusing all those areas. So remember that it's area under the curve. So that's a 1. This is a negative 1, a positive 1, and a negative 1. So if you make all those areas positive, you really have this blue rectangle here that went 4 units over on time at a height of 1. So 4 times 1, area under that curve is 4. So that leads to the concept of consumption over time, in which velocity is considered to be a consumption over time function. So it's a rate in which you can integrate to find a total. It's a rate that you can integrate to find a total. In fact, if you're given the function of number of tickets police gave per hour, then you would be able to find the total number of tickets given in a 24-hour period because you can integrate. This concept is utilized a lot when it comes to erosion of land. So the beaches currently, actually in some of the foreign countries, are eroding away right now on popular resorts down inland Mexico. So they're using this idea to add sand back and build up their beaches. So if you've ever been at the beach and you see like those black tubes, what they're doing is going underground, bringing sand up, and they're raising the level of the beach. So this is actually something you might have seen. So it says the time removes sand from the beach at a rate modeled by R. Now, immediately I see these decimals because this is a calculator question. So you can get your calculators out. You can utilize a calculator to help you through this. So R of t is what I would immediately put in my y equals. So I would immediately go to my R function and type that into y1. I would make sure that my function is in, or my calculator is in radians. So I would put R into y1. I might even make a note of that on my paper as I'm working through this, just so I remember. Because we're going to end up with two functions in our calculator. We're going to be adding and subtracting sand away. So we're starting with the adding. And we're going to incorporate, we're starting with the removing and going to incorporate the adding. So I would put S of t in y2. So I got my y1 and my y2 all set up. R of t and S of t are in cubic yards. So that tells me they represent volume equations. It says at time t equals 0, the beach contains 2,500 cubic yards of sand. That's my initial condition. How much sand will the tide remove? So we're talking about R from the beach during a 6-hour time period. So 0 to 6 of R of t dt. So that's all you have to write on your AP test if this is a free response question. And then tell me what it equals. You don't have to write R of t down. Remember I said be function specific? Putting R of t like that means you don't have to write all of this. Go over to your calculator. So I have these in my calculator as my functions. I'm going to go to my home screen. I'm going to hit math, go to 9, type 0, 6, bars, y bars, bars, y bars, function, y1. Tag that X on at the end and hit enter. So after 6 hours, the tide has removed in terms of words, what that means is at t equals 6 hours, the tide has removed 31.816 cubic yards of sand. Part 2, or Part B, asks, what is the total amount left after that time period? So write a new expression. We're going to call that new expression y, that represents the total number of cubic yards of sand at the beach at any time t. So y of t represents final. So we know that final needs to take into account initial. So initial is 2,500. And then we need to know how much sand is being added and how much is being removed. So S of t represents adding, R of t represents removing. So you could write it as 1 integral or 2, but it's the amount added minus the amount removed from 0 to t, knowing what you started with. So of course on the AP exam, they're not going to just ask you to give this. They're going to ask you to give this for a particular hour. Rate in, rate out. So the particular hour they want to know is 4. So find the rate at which the total amount of sand on the beach is changing. So it asks me to find the rate. Right now, what is this finding? It's not finding the rate, it's finding the amount of sand. So what is a rate? A rate is a derivative. So the derivative of this would be y prime of t. What happens to the derivative of a constant? The derivative of an integral? They cancel, right? So d dt of an integral, they cancel. That is part 2 of FTC. So y prime of 4 would be s of 4 minus r of 4, which you could easily get from the table on your graphing calculator. So it would be s is in y2. So that's 60 over 13 minus 6.5241, which is negative 1.908. The derivative, if s of t is yards, and this is a rate, or yards cubed rather, and this is a rate, then that's cubic yards per hour. So sand is being removed because it's negative. So they are losing about 2 yards of cubic sand per hour. They are losing about 2 cubic yards of sand per hour on the beach. Okay, and then the last one, it says find the minimum amount of sand. So what time is the amount of sand on the beach a minimum? At what time on the beach is the sand a minimum? So you need to take into account that a minimum is going to occur when the derivative is 0. So we just said y prime of t was equal to s of t minus r of t. A minimum occurs, or a maximum occurs, at a 0. So what you would need to do is find when r of t equals s of t. And again, this is a calculator problem. So you could use your graphing calculator. So I had the table up because I found r of 4 and s of 4. So we're only looking at the interval from 0 to 6. So I know my window can be 0 to 6. And again, you could just kind of hit graph where you are now. See if you get both lines. So there's my sand being removed. Here's my sand being added. So where do they intersect? They intersect over here. So I'm going to go to second trace intersect. And I get that they intersect at 5.117. So this is an EVT question because it is a closed interval, which means I need to create a table of values incorporating my beginning and my end, as well as my intersections. So you need to know, okay, 0, 5.117, and 6 from your table. So if these are the times, it says find the value. So remember, we're finding y prime of t, which is s of t minus r of t. So you would have to do 0, which is 0 minus 2, or negative 2. Here it's 4.6942 minus 4.6961. And at 6, it's 90 over 19 minus 2.6267. So you get a negative 0.0019. And a positive 2.1101. Now remember that those values represent the rates. So that's like a negative velocity or a negative rate, and a positive rate. So in terms of our points, it's like decrease to increase. So our total amount of sand, in order to do that, you would have to actually take your integrals to find the value. But our minimum would then occur where it changes directions. Okay? There's your packet. Did I give you problems? Okay. Homework is in our book. (17 to 27), odd, 31 to 36.